Hello, I am Brock Stanton. I am an aspiring meteorologist, and today we are going to be talking mostly about this enhanced risk for severe weather across portions of Kansas and Nebraska. However, I do think that based off the most recent model trends, this could end up being shifted or expanded some areas further west and south, perhaps into areas like south central Kansas, southeastern Kansas, perhaps extreme northern Oklahoma. Just because that's the area where there's the highest confidence to storm coverage, and we'll discuss more on that later. But really, anywhere that has this risk of significant severe weather highlighted in this hatched area, we see the chance for more significant severe weather, and we can see how the slight risk does expand from all the way portions of North Texas up through southwestern Iowa. So, day where there could be a good bit of severe weather, and we'll discuss that a little bit later. But I'm not going to be talking about these days as much in detail, but there are these day 4, 5, and 6 risks as well that all do suggest a chance of some severe weather. Damaging winds, hail, and tornadoes are possible each day. But before I get further in the video, this is day 3, so I just want to apologize for not being able to upload on Monday and Tuesday. My voice might sound a little bit off. I've been sick the last couple of days, still am a little sick today, but I feel a lot better today, and given the fact there is a enhanced risk now, because this was only a day 4 and 5 slight risk, given the fact it was upgraded to enhanced risk and I'm feeling a good bit better, I decided I'm good enough to upload today. Now we're going to take a look at our NAM 3K, and we're going to see how this is during the morning on Friday, and we're going to see how these storms here, these are likely more elevated storms. Let's just check a sounding and see. Yeah, these are elevated storms, probably have perhaps a chance of large hail based off of that, maybe a damaging ones, but with this area, tornado potential wouldn't be not really too much because there's just not enough moisture. But as we shift further east, we can see the NAM fires these storms down here, and these storms clusters evolves up here. That's why the slight risk will expand so far north. And then this NAM also tries to develop this overnight squall line as well, as far as we can see. But the area that the storm road that I have the most concern for is these storms down here. I know they don't look quite as intense on the NAM 3K, but the overall environment is conditionally favorable for significant severe weather. And the reason I say conditionally favorable is because there is a capping inversion aloft, a layer of warm air, and that suppresses thunderstorm development. However, if that cap breaks, but if that cap breaks, then storms will erupt, and when there is still a weak cap in place, which is what would happen this day, storms can break through that, but that weak cap still being in place can support a more discrete storm mode, more isolated storms. And given the other environmental parameters, that does favor an elevated chance for tornadoes. So, this mode here is what I have a lot of concern about. And can we just take a sounding here just east of them? You're going to see that photograph does turn some. This sounding has very little convective inhibition, but we're going to see where I have strong cape in that quarter just east of the dry line, and that if storms fire, and that could favor all hazards of severe weather. We're going to take a look at the dry line now to see where our low-level forcing is going to be. And as we see by 21Z, the dry line really begins to sharpen. And look at by 21Z, you can see as our storms firing are in 23Z, by the way, this is 6 o'clock Central Time. You can see our sharp dry line, mid to upper 60s dew points. That's a very moist and unstable air mass. Just going to take some soundings along here. You can see our turning photograph, a relatively weak cap in place. So that does suggest thunderstorm development is possible along the dry line. We'll take areas further south, close to the Oklahoma City area. And again, the NAM is showing a weaker cap, though I think the mid and upper level forcing might not be quite as strong in these areas further south, because despite the weak cap, the NAM 3K doesn't fire any storms in that environment, but that could definitely change. Models were not firing really any storms in this environment yesterday as a whole across Oklahoma and Kansas, and now it's initiating storms in Kansas. That just goes to show how things can change. So to see our dry line, how we have a robust moisture return for this setup. We're now going to take a look at our cape, mixed layer cape, and we can see how as we get into the day on Friday, here they're getting into the afternoon hours, we have this strong instability. The NAM's hinting at along and east of the dry line, perhaps some cape values over 3,000, but definitely widespread over 2,000 east of the dry line. There we go, our storms fire, they move into that strongly unstable environment. And again, these values, the storms don't really initiate down here into Oklahoma until perhaps that overnight line, but I do think thunderstorm development is still possible here, and significant hail, tornadoes, and damaging winds would all be possible with this, with storms that do form. So that's why I'm concerned about severe weather across really Nebraska, especially Kansas, and portions of Oklahoma as well. We're going to take a look at our 850 jet. This is very important for assessing especially our damaging wind and tornado potential, because it tells us what the winds are, what our low-level wind shear is, and that's really important for seeing wind and tornado risk. So we're going to see by 21Z, this is our 850 low-level jet axis, 850 jet axis, and we're going to see that the strongest winds generally span from points Oklahoma City and points north by 21Z, and we can see, especially across eastern Kansas, here there are access of 40 to 50 knot winds, which would favor the strongest and highest chance for tornadoes with supercells that move into that environment. You can see, especially by 0Z, our low-level winds, this is now 7 o'clock Central Time, just for a reference point. Storms, no, not our storms here, but our low-level winds are even stronger, so again, any supercell in this environment would have a chance for very large hail, damaging winds, and tornadoes, and depending on how things trend, we'll have to see how tomorrow, especially if that cap were to break and we get a discrete supercell out in this environment, I would not rule out the chance of a strong tornado, because our low-level shear values, especially by 22Z, 23Z, so that's 5, 6 o'clock, do really start to increase. So if we have a discrete supercell in that environment that supports all hazards, again, significant hazards would be significant. How the Storm Prediction Center defines that is winds, straight line winds greater than 74 miles per hour or greater, I should say, hail 2 inches or larger, and tornadoes that after the fact end up being rated EF2 or higher. So we can see those 850 winds are very strong. And we're now going to take a look at our bulk shear. And we're going to see how, as we get into the day on Friday, these are going to be sufficient for organized storms. They're not as incredible, but they're still sufficient, especially across this area in south central Kansas, so the storms could perhaps be areas a little bit to the east. We can see, as we get into the evening hours, this turning hodograph supports, again, all hazards of severe weather. Again, this is probably along and just east of the dry line, increasing into the evening hours, there's that greatest chance of storms. And wow, that's a really impressive sounding there. I don't know whether this will come to fruition or not, but see our curving hodograph, our temperature dew point spread is very, very favorable. It's less than 9, so that has our lower cloud heights. Still strong instability, breakable cap. I don't know whether storms will fire in that environment because we need strong enough forcing. I don't know whether we're going to have that, but this sounding right here in south central Kansas is very favorable for tornadoes if a storm were to mature in that environment. We're now going to take a look at our storm relative helicity values, and we're going to see how, again, eastern Kansas does have the highest values, but as we shift, as the low-level jet intensifies, it expands a little further west, and that's why the tornado threat, again, if a storm can mature in it, does increase. Guys, this is probably just like the exact same spots here. Yeah, it's basically the exact same sounding. I don't really know why I clicked on that. We can see really anywhere over 200 is where, if you get a mature supercell to develop, you can see a stronger tornado. Up here, that's really not going to probably be the case. We're going to be dealing with a linear mode, but this quarter down in here, there is a chance that you could see a discrete supercell, and if that's the case, can't rule out a strong tornado. We can see our 0 to 3 values also going to be very favorable. For strong tornadoes, you want to see values over 250. So you're going to have that over a very large area. Areas greater than 250 are like this orange color. Have that over a lot of places. But I did mention the capping inversion. I want to show that before I get too carried away with myself showing myself these parameters. But our capping inversion is quite on how much it erodes is a big uncertainty with this risk. But we see by 21Z, this corridor here, where if we take a sounding, I believe that should be just east of the dry line. Maybe just go a bit farther east. That did seem to be right along the dry line, but you can see that quarter just along to the east of the dry line, however much that capping inversion erodes is really going to be determining exactly how widespread this severe risk is going to be, because overall the environment does seem favorable for all hazards. It's just whether a storm can punch through that cap and take advantage of the otherwise strong environment in place. Just take a little environment, we'll go a little farther north. You can still see how there's perhaps a little more convective inhibition in that sounding, but still that turning hodograph, good temperature dew point spread, moderate instability. And we can see how by 1Z it does, well, that's their squall line forming this. That's just really behind the line, but you can see their pushes south. That's just our advancing squall line, though. So we're going to switch subjects a little bit. We're going to talk about our hail risk now, because that's what's defined as the 30% significant right now. If you can see by Friday afternoon and evening, let's go 21Z. Again, this is 4 o'clock Central Time. This widespread area that has very steep lapse rates, and that's why we are confident that with any discrete cell that does develop, there's that hail risk. And that's why the Storm Prediction Center has highlighted this 30% significant for hail, and this entire significant area by the SPC is for it's not for tornadoes. I'm confusing words here. It's for hail. 15% and 30% significant for hail. However, based on how things changed, it would not surprise me if the tornado's probabilities increase, which I know it doesn't specifically say what they are in that, but based off the text wording, it's currently a 5%. But wouldn't surprise me if you see an increase to 10% or 10% significant in the coming days, tomorrow or day of, just dependent on how that capping inversion breaks, of course, but models have trended towards a quarter of a weaker cap, and that could favor a robust supercell development in an environment that has strong low-level shear, so that makes me think a strong tornado is possible. But with that, we saw what our NAM shows now, and we're going to take a look at our Euro now, and we're going to take a look at our 850 jet first, just kind of see the overall setup on what it tries to do. We went a little too far, yeah. So that's 0Z, a little bit backwards there. So there it is by 21Z. Here's our quarter of 30 to 40 knot 850 jet, and as we move it east, move it to 0Z, so this is 7 o'clock, you can see how that's this quarter of a 50 knot low-level jet developing across north central Oklahoma, south central Kansas. I'm just curious to see how the Euro does with the capping inversion on this. Yeah, it has a stronger cap in place, which is taking a look at that, 'cause that's really the thing that has the biggest uncertainty with this setup, and that kind of makes or break how the setup evolves. The Euro does seem to hold a little bit more of a cap, but let's just take a look and see how it handles precipitation with it. Does it firestorms? And it looks like to me that it tries to initiate these storms here. Here's our overnight squall line, but for this initial mode, it tries to initiate them, but it's kind of unclear. Look, there's these storms trying to initiate down there. The Euro, I remember, had from what I looked at before this before this recording, it shows the dry line much further east than the NAM. However, that does seem to be an outlier. Here it is by 21Z. If we remember, our NAM was something more like this. But if I recall correctly, the GFS 12Z, you can look at the 18Z in a second. Yeah, had it further west, more similar to the NAM. Get a very sharp dry line. But we're actually, so before this video, I looked at the 12Z GFS. So let's take a look at the 18Z GFS together. Why not? We're gonna see pretty similar to the 12Z. That by 21Z, we have our pretty sharp dry line here, west of the Oklahoma City metro, up to portions of Kansas. It still does seem, especially across portions of Kansas, a little bit further east than what the NAM shows. Looking for 12Z just to see if that did shift east. If anything, it maybe shifted a little bit west, but pretty similar spot overall. So let's take a look at our instability now. Let's see how that develops. Here's by peak heating. Curious, just take a sounding here, see how it's handling the capping inversion. See a pretty weak cap in place. At least sufficient moisture return with that strong heating to support a tornado risk. Here, strong instability. Looks to be pretty decent wind shear, strong wind shear. But let's just take a look at our 850 winds and determine that for sure. And okay, wow, that's a very strong wall of Leggett by 0Z 7 o'clock. Just take a broad sounding here across southern Kansas and northern Oklahoma, and you can see how the capping inversion is stronger, and so that does lead to some uncertainty with storm coverage again. But the storms that do form in this environment will be capable of significant severe weather. We're going to take a look at actually, I want to look at something on the NAM that I never showed. To go to our NAM 3K. I never ended up showing our surface-based CAPE and hodograph overlap, but I think this is a really nice tool that is here. So sometimes I forget to show it in my videos, but so if you can recall from when I show soundings, we generally look for that in the top right, the turning and hodograph, to identify tornado potential. And then instability, we generally want to see values over 1,000 for tornadoes. In this case, we have values much higher than 1,000. But as we look here, we can see there's some turning in the hodographs into the afternoon hours, but it's really by 22Z5 and 6 o'clock that we get the most turning as that 850 jet strengthens. So that just kind of shows how if we have a discrete storm by 23Z, I bet we'll get a pretty favorable sounding here. Yeah, we will, because that turning in the hodograph, our robust moisture, it's a very strong CAPE, our pretty weak capping inversion. And that's what shows our potential for significant severe weather. But I do want to take a look at that GFS as well, so we show multiple solutions. Our NAM does certainly seem to be the most aggressive, but you can see by 0Z, there is still that turning large whooping hodograph, but there is a tiny bit more of a capping inversion, so that does leave us a little more uncertain with storm coverage. And that, again, I probably sound like a broken record saying this, but it's going to be that capping inversion is going to determine this event. Overall, the ingredients seem to be there for significant hail and tornadoes, but if the capping inversion is just too strong, then storms are going to be very, very isolated in coverage, or perhaps not fire at all. I will say over the last 24 hours, the models have trended towards a weaker capping inversion, hence why there is now an enhanced risk for severe weather. So I tend to think we'll see at least a couple storms form in this environment, but it is still a little bit of a conditional and uncertain threat. However, the ceiling for this event is pretty evident that it could end up being a very significant severe weather event. We just have to see how stuff trends, and here's by 0Z our capping inversion of the GFS. These areas that are generally in the yellow or less, or yet like yellow, or like these grayish blues colors, and the white side show a more favorable cap for support severe weather. Once you get into these oranges, it's not too much of a capping inversion for surface-based severe storms most of the time. Again, I do think that cap's going to break, at least in isolated areas, and where that does happen, we could see significant severe weather. I do think that's going to be the end of the video. If you did enjoy it or find it helpful, please consider to like and subscribe. And if I remember, the link to my Twitter will be in the description, though I think I ended up forgetting from my last video, so hopefully I don't do that again. But I will be uploading another video tomorrow, and I will see you then. Bye.